So I'm going to try to attempt problem number 222 from the book. It's asking us to find df dt and then do it again using direct substitution. So we'll substitute in uh, uh, t for x and then t squared for y as we do it a second time. So let's do the chain rule. So we need fx, which means the derivative of this function with respect to x. And the derivative of that square root, so 1/2 times x squared plus y squared to the negative 1/2 times the derivative of the interior with respect to x, which is 2x, and then dx dt. Well, x is t, so the derivative of t is just 1. And our others are fy, which is the derivative of that with respect to y. So again, we have 1/2. This is x squared plus y squared to the negative 1/2, but the derivative of y squared is 2y. And finally, dy dt is 2t. So that df dt, using the chain rule formula above, we combine all this, the 2's cancel and the 2x and the 1/2 as well as the 2t, x, and so forth. So we have over here x over the square root, and then that's multiplied by 1, so we don't worry about it. And then this next one, the 2's cancel, we have another 2, so that's going to be 2t y over the same square root. And ultimately, this equals x plus 2ty over the square root. And this is the answer. We can also maybe substitute in those values for y and x to get it all with respect to t, but for now it doesn't matter, but I'll show you in a bit as far as how that goes. The next thing we're going to use is direct substitution. So that means our f evaluated xy equals t squared, because x is just t, and then this will be t to the 4th power. And again, this essentially is the same thing as t squared plus t to the 4th and to the 1/2 power, which means the derivative of this is going to be 1/2 t squared plus t to the 4th to the negative 1/2 times what the derivative is inside, which is 2t plus 4t cubed. And this equals, I can pull out a 2, cancel that 1/2, which gives me t plus 2t cubed. In the square root on the bottom, I can pull out a t squared, which turns into a t. That gives me root 1 plus t squared. I can pull out a t and cancel those, so that's 1 plus 2t squared over root 1 plus t squared. All right, so looking at our answer from above, let's do a little bit of substitution there. Sub in for x and y. So we sub in for x, that gives us a t. So that's plus 2t, and then we get the y, which is t squared, over root t squared plus t to the 4th, and that gives us essentially what we have directly below. So again, we can factor out a t from each, and that gives us t times 1 plus t squared, 2t squared, excuse me, over t and then root t plus, excuse me, 1 plus t squared. The t's will cancel, and we're left with the same answer that we got below. This, however, is fine. You don't have to substitute in the t's. I just wanted to show you that those two answers were actually equivalent.